Okay, so yesterday we introduced properties of inequality. We reviewed properties of equality, and the properties of inequality are very similar, except the operator that you have between your two algebraic expressions is an inequality, not an equal sign. So we have the addition property of equality, the multiplication property of equality. We've already talked in class about the fact that subtraction is just the adding of a negative number. So that's why subtraction still works with the addition property. And we had an example there. So there is an example. So example 1 on page 149 asks you to both solve and graph the solution to the following inequality. So let's go ahead and look at example 1. It's like super, I don't know, tiny. So the first one they give us is x plus 7 is less than 8. And a lot of these you should be able to sort of find your answer in your head, but we're just kind of getting comfortable with doing our properties of inequality. And then the third one is negative 0.6. Yay, decimals. Is less than or equal to x minus 0.4. Okay, so what do we need to do in A to isolate our variable x and find our starting value for our number line? Right. So the opposite of addition is subtraction, or we are adding the opposite number, and the opposite of a positive 7 is a negative 7. Think of it either way, same difference. So we have x that cancels itself out, and you're left with x is less than what? Right. So as long as x is less, we're crying out loud. Here we go. As long as x is less than 1, then it's going to make this a true statement, the inequality. So you draw your number line. X is 1, so that's what I'm going to put in the middle. You don't have to get too fancy. So that's 1, 0, negative 1, 2, 3, 4. Nope, no 4. And I'm starting my number line at 1. Open or closed? Open circle, because it does not include 1, but starts at 1 and then includes everything smaller than 1 or at a lower value. Okay. B, we have x minus 5 is not equal to 3. So again, we're using our addition property of equality. The opposite of a negative 5 is a positive 5. So we're adding 5 to both sides, and x does not equal 8. So put 8 in the middle, 7, 6, 9, 10. All right, what kind of circle do I put at 8? Open circle at 8. And which direction does my line go in? Both, right? It can be less than 8 and it can be greater than 8 as long as it's not 8, right? All right. We all feel pretty comfortable with this. Makes sense? Okay. Good. X minus a 0.4. So to isolate our variable in this case, we're going to add 0.4 to both sides. And so we have x is greater than or equal to, that's a negative 6 plus 4. So that's still negative because 6 is greater than 4, but it's a negative 0.2. Now, use your symmetrical property of equality to rewrite that. X is greater than or equal to negative 0.2. See what I did there? All right. If you flip your variable and its value, you must, so it says the same thing. So negative 0.2 is less than or equal to x. means that x is greater than or equal to negative 0.2. So, and that way you're putting your arrow in the right direction so that when you draw your number line, let's see. So I'm just going to go with a -1, -0.8, -0.6, -0.4, -0.2, 0. Right. -1. A little bit bigger so you can see it in the back. All right, so we start at -0.2. What kind of circle do we have? Right, we've got a closed circle. I don't know why that negative is like below the 0.2, but okay, we understand that's negative. And what direction do we go in? Right, it's greater than, x is greater than or equal to negative 0.2. All right, any questions? We good? Okay. It's the details that get important. So if you are switching it, make sure you switch your inequality sign. Okay. So scientists use experiments to test a hypothesis. In mathematics, the truth of a hypothesis is examined in each possible case. So let's look at these test cases that they've given us to see whether inequalities are always solved like equations. So for case 1, they have 3 is less than 5. They have 2 times 3 is less than 2 times 5. And they have 6 is less than 10. So is 3 less than 5? Yes. Is 2 times 3 less than 2 times 5? Right? Because 2 times 3 equals 6, 2 times 5 equals 10, and those are still, why is that so weird? There we go. And those are still true. So your statement is true, multiply both sides by 2, and the inequality is still true. So let's look at another example. Case 2 gives us 4 is less than 6. And then we multiply both sides by -2. So is -8 less than -12? True. Well, we can't really state whether that middle one is true, but when we solve it, we find that it's not. Why? What just happened? Can anybody articulate it? Like, it makes sense, right? When you multiply a small number, like a smaller number, times a negative, it is still a smaller number. But what happens when a smaller number becomes negative? Its value, right? Its value is greater because it's closer to 0. Right, so it's close, it's farther right on the number line. So when you graph it, actually, I'm gonna do this in 2s. Let's see, let's do -14, -12, 10, 6, 4, 2, 0, 2, 4, 8, 10, 12, 14, right? Okay, so this is -14 to +14. 12, 10. This is 0, just so we've got a scale here. All right, so -8, or let's look at this different. 2, 4, 6, 8. So here's 8. And 10, 12. Here's 12. But then on the number line, 2, 4, 6. Here's -8. And here's -12. Right, so the smaller number in negatives is closer to 0, which is closer to positive, therefore it has a higher value. So whenever you multiply times a negative, hold on, let me put it the way they put it so I don't say this wrong. Okay, case 2 illustrates that if you multiply both sides of an inequality by the same negative number, you must reverse the inequality symbol to make an equivalent inequality. What does equivalent mean? equal, right? So to make it to make it still be true, or to make it say the same thing it did originally, when you multiply times a negative number, the same negative number on both sides of an inequality, you must flip your inequality symbol. Everybody remember this from like basic arithmetic when you were studying inequalities? Okay. Remember that multiplication and division are inverse operations. Dividing by 2 is the same as multiplying by 1/2, because 1/2 is what to 2? It is 2's reciprocal. Yes, so remember reciprocal. We talked about that yesterday, if I can find it. Goodness, there it is. Right? So if you have the number 5, it's opposite. Opposite makes it, changes the sign. Reciprocal inverts it. So it's 1/5. 2/5, its opposite is -2/5. Its reciprocal is 5/2. So when you divide, all you're doing is multiplying times the reciprocal. Okay, so the principles that hold for multiplication will also hold for division. If both sides of an inequality are divided by the same positive number, you still have a true statement. If both sides are divided by the same negative number, your inequality symbol must be reversed to form a true statement. So let's see what this looks like. First, you have your multiplication property of inequality. And this tells you that if A, B, and C are real numbers, or expressions, remember algebraic expressions, they've got variables, such that A is less than B and C is greater than 0, which means it's positive, then A times C is still less than B times C. Or if C is less than 0, which means it's negative, it's supposed to be then A times C is greater than B times C, which is just using variables to represent any real number, kind of like we saw in the cases that we just looked at. Now, as with the addition property, we are using the less than symbol with the A is less than B, but that works with less than or equal to, greater than or equal to, or negated, not equal to. So let's look at some examples. We have -3x is less than -9. We have x divided by 12 is greater than -4. And we have -5/2 times x is greater than or equal to 25. Does everybody have the multiplication property of inequality? Y'all still writing? All right, so let's look at example A. -3x is less than -9. All right, so what do we need to do to isolate our variable x? Right, we've got to divide by -3 to both sides. So this side becomes just x. Because it's negative, we reverse our inequality symbol. So instead of less than, it becomes greater than. And what is -9 divided by -3? positive 3. So let's check our answer. Let's say we have negative 3. Now, when you check your answer, go back to your original problem. So what's a number greater than 3? Let's just go with 4, right? So negative 3, plug in 4 for a value of x is less than negative 9. Well, what's negative 3 times 4? Negative 12. Is that less than negative 9? So we're good, right? So what if we had forgotten to switch our inequality symbol? And let's say we had x is, don't change that in your notes, I'll change it back. X is less than 3. So when you plug in to check, what's a number less than 3? We'll go with 2, right? And what's negative 3 times 2? Negative 6. Is negative 6 less than negative 9? Nope. Because it's negative. So it's closer to 0. It has a greater value. So when you check it, if you plug in something that matches that x solution that you've solved, if it doesn't work, you probably forgot to flip your inequality symbol. So make sure that you switch it and then check it. All right, let's do B. They want us to graph it. They did want us to graph it. All right. I think we're good with that. We know that x needs to be a number greater than 3, but I'll go ahead and graph it for you. All right, 1, 2, 3, 4. All right, so it does not include 3, and it's any number greater than, which we can test that out and find out that it's true. Okay, so for B, x divided by 12 is greater than negative 4. All right, what do we need to do to isolate our variable? Right, so we multiply both sides by 12. These cancel out, so x is left the same. Do we need to reverse our inequality symbol? What are we multiplying? Is the number that we're using to multiply both sides negative? No. Right, so because that 12 is positive, even though negative 4, the negative 4 is already over there. We're not multiplying both sides times the negative number, so we're not changing the signs. Therefore, you leave the inequalities the same, and you get x must be greater than negative 48. And we can graph that. So we'll put negative 48 here, negative 47. Just make sure you recognize they're negative, and so those numbers get smaller. Negative 49 and negative 50. Is our circle open or closed? It's open, right? It does not include 48, and it must get greater than 48. All right, so let's check. What is a number greater than negative 48 that we can put in for x? So what is the number greater than negative 48 that x divides evenly with? I'll do negative 36, right? Or negative 12. Negative 12 is greater than negative 48, right? Let's do negative 12. Negative 12 over 12 is greater than negative 4. What's negative 12 divided by 12? Negative 1. Is that greater than negative 4? You look confused. Yeah, you know what I did? We're good. I mean, I'm just picking something, and I know in my original problem I have to divide, so I'm going to pick something that 12 divides into. So I'm not working with crazy fractions. Yeah. Okay. C. Right along here. Negative 5 halves times x is greater than or equal to 25. All right. What do I do to isolate my variable? So Trey, what do I need to multiply times both sides? Yes. So we need to divide both sides by negative 2/5, which is the reciprocal. So we're multiplying times a reciprocal. Now you could do it in 2 steps. You could divide both sides by 2 and then or I'm sorry, multiply both sides by 2 and then divide both sides by -5. Yes.
Would it also be -0.4?
You could convert it into a decimal if you wanted to as well.
So you multiply first.
Well, if either way, they still cancel each other out, don't they? So then if you go over here, -2/5, you could do it either way, right? You could divide 25 by 5, which gives you 5, and 5 times -2 is 10. Or you can multiply 25 times -2, which is -50, and divide by 5, which still gives you -10. So it doesn't matter which one you do first, because you're still multiplying 25 over 1 times -2/5. So the 5 cancels out, 25 becomes a 5. So we're left with x. Now, what do I do with my inequality symbol? Do I keep it the same? Got to flip it. And then 5 times -2 is -10. So x must be less than or equal to -10. So let's graph it. I'm going to do this in 2s. So -2, 4, -6, -8, -10, -12, -14. All right, so my line starts at 10. -10, is it open or closed? It's a closed circle completely filled in, and it goes to the left because it's less than. So let's test it out. I'll pick what, -12? We can do -12. -5 over 2 times 12, I'm just going to do 12 over 1, is greater than or equal to 25. Sorry, that's a -12. Okay. So these guys cancel out. That 2 becomes a 1 and that 12 becomes a 6. And what's -5 times -6? You look very confused. Have I lost you? No? Okay. Huh? Yeah, it's +30. Is 30 greater than or equal to 25? Yes. So we're good. Okay. Now let's look at a word problem. Is this the one you looked at yesterday and you were like, why is it money again? Okay, so example 3. We have how much money must be invested at 7% simple interest to produce a yearly income of at least $875,000. So in this case, our unknown is our principal. So the reason we know this is an inequality is because of what phrase in our word problem? How much money must be invested at 7% simple interest to produce a yearly income of at least $875,000? So you're like, this is how much I have to have. I would enjoy the gravy, so I would like to make more, but this is my minimum, right? So because you have the expression at least, that tells you you're working with an inequality. So it's still the same thing we did in the money problem from the previous chapter when we were working with interest rates. However, instead of equals, we just use an inequality. So P is our unknown. That's the amount invested. And so P needs to be what compared to $875? If it needs to be at least, then Matthew, what does it need to be? P is at least 875. Yes, it must be greater than or equal to. So that's our problem that we're trying to solve. We've got to figure out what number that is. So let's make our table. These lovely tables. This one is super small. You just have P. So what am I trying to say? Principal times rate times time equals our interest. Our principal is X, or let me just keep it the same, it's P. Our rate is our interest rate. So what is our interest rate in decimal form? 0.07. And our time, he's saying he wants a yearly income, so it's just 1 year. Therefore, interest is 0.07 times P. No. Yes, no. Principal times rate times time, yeah. Equals, sorry. Symbols up here. All right, so we take 0.07 P is greater than or equal to 875. So to isolate our variable, we divide both sides by 0.07. And we find that the principal must be greater than or equal to $12,500 if they want to earn $875 at the end of the year on a 7% interest. All right. So how do we check it? This was pretty simple. You just plug in that value for P. So 12,500 times 0.07. And we already know because we just did it that it equals 875. So if they have, 13,000 or 15,000, they might want to invest all of it so that they get more than $875 back. Okay. So it's Wednesday, so no homework. Let's go ahead and start it in class and then we'll finish it tomorrow. Yeah, go ahead. Let me find my notes for today. Let's algebra. All right. So the homework that you are not doing at home, just so you have it in your notes, is on page 151, numbers 2 through 32 even. Okay, so number 2. So 2, 4, 6, and 8, it wants you to solve and graph the solution to each of the following inequalities. So 2 is x minus 2 less than or equal to 3. 4 is 4x is greater than -2. 6 is negative x over 2 less than 4. Last one, 8. X minus 8 is greater than or equal to -8. Okay. Just gonna go ahead and put this up so people that are watching the video can pause it and take a check their answers. Are you guys checking them as you go? Oh, you just got back. Okay. And so there is 10 through 16. If you want to check your answers. How'd you do? Hopefully the only tricky one was 14 and 16. It's also possible that you forgot you were subtracting a -5 from a -6. So you needed to add those like terms for number 12. But for number 10 and 12, because you're using addition, you do not change the sign, even though you do have a negative for number 12. 14 and 16, and one you're multiplying, the other one you're dividing, but they're both negatives. So you have to switch your inequality sign. All right, we still have about 6 minutes. Let's see, I want to try 18, maybe 18 through 24. See if we can get those done. So for number 18, we have 2/5 times s is less than or equal to -4/15. So what do we do to isolate our variable? Yep. So you multiply times the reciprocal to both sides, 5/2. Which is nice because when you write it that way, then you see you can just cancel out. So that 15 becomes a 3, the 5 becomes a 1, the 2 becomes a 1, and the 4 becomes a 2. And those guys, of course, cancel out. So this is s is less than or equal to -2/3. So again, because the number we're multiplying times is positive, we do not change our sign. So s is still less than -2/3. So for number 20, we have -3/4 times t is less than -9/10. So what do we multiply times both sides? -4/3. And you can reduce those again if you want. But because we're multiplying times a negative, we have to make sure that we switch our inequality sign because that -9/10 just became a positive number. Let's see, that becomes a 3 and that's a 1. That could be a 2 and that is a 5. So 3 times 2 is 6 and 6/5. So t must be greater than 6/5. All right, number 22. All right, let me get that all to fit there. All right, so 2 times 4n is less than 6. What do you want to do first? In mine, it's multiplying. Is that 2 times 4? Or 2 minus 4? I know, they wrote it in a way that is extremely confusing. But we want to simplify first. What's 2 times 4? Yeah, you can, because you're multiplying them, even though they're unlike terms, you're multiplying them. So you can still multiply 2 times the coefficient 4, and it's a valid solution. So multiply the 2 times the 4, so you get 8n is less than 6. And then what do we do to isolate our variable? Yeah, divide both sides by 8. And so n, 8 is positive, so we don't have to change our inequality, but we do need to reduce that fraction. 6/8 reduces to what? 3/4. Yep. Okay, we'll do 24 and then I'll let you guys go. So for number 24, again, we have sort of a complicated one. Just don't forget you need to simplify first. This is 7x times 2 is less than -12/5. So that's the same thing as, well, it's just you multiply the 2 times the coefficient 7. 2 times 7 is 14. So we have 14x is less than -12/5. And then what do we do to isolate our variable? Yep, we divide. So we divide both sides. So this means we're, why am I having a moment here? Okay, hold on, let me just write it this way because I'm so confused right now. We are multiplying both sides times 1/14. Okay, good. That's what I thought. But then I just sort of, my brain sort of short circuited for a second. Okay. So dividing by 14 is the same thing as multiplying times 1/14. Yes, right. Okay. Whew, that hurt for a second. Sorry. And the 14 is positive. The 1/14 is positive. So we keep it the same and we can reduce. So that 12 becomes a 6 and that 14 becomes a 7. It's a little easier. So -6/35. So as long as x is less than -6/35, you have a true inequality. All right, we will work tomorrow on those word problems.